So, just before we start, could we jump right into the geological timeline of approximately 4.5 billion years old of the Earth that we have created till now, so that everyone gets an overview of how it works, so that we can get into further questions?
Right. So the Earth is now well known to be 4.5 billion years old. And getting that age was a non-trivial thing. I think it's more than we want to go into right now, but that's a well-constrained age. And it's based on isotopic dating, which really wasn't available until the mid 20th century. Prior to that, the basic way of calibrating the geologic timescale was fossils. And so the part of the geologic timescale that most people will have heard of would be the last 500 million years of that 4.5 billion year history. And that's the Cambrian period to today. And that is very well calibrated because the 19th century Victorian geologists around the world, Victorian era geologists, really knew their fossils, and they did a great job of dividing and subdividing all the periods and epochs into very fine divisions. But that is just the last 1/9 of the geologic timescale. So let me give the really big overview. So the Earth is 4.5 billion years old, and we have at the longest stretch of time eons. And there are, let me think, 3 great eons in Earth's past. The first one is called the Hadean, and it lasted 500 million years, and it's defined as the era or the eon for which we actually don't have any surviving rocks on Earth. So in Earth's infancy, I like to say, it doesn't have any memory of what happened. We do have rocks from the moon and meteorites that actually help fill in what was going on during that first 500 million years, but we don't have any Earth rocks except for a couple of tiny little crystals of a very durable mineral called zircon that clock in at about 4.4 to 4.3 billion years. So we've only these tiny, literally sand-sized particles left from the first 500 million years of Earth's history. That's the Hadean, the hellish time is what it actually means. And then the next great eon, actually there are 4, sorry, I miscounted, is the Archean, which just means the old time. And that lasted from 4 billion years ago to about 2.5. And I like to think of this as the childhood of Earth, where it would not be a recognizable planet to us. The atmosphere was dominated like the atmospheres of Mars and Venus by carbon dioxide and water vapor. No oxygen, no free oxygen in the air. Life emerged during this time, probably at least 3.5 billion years ago, maybe a bit earlier than that, based on fossils of microbial mats that are called stromatolites. But it was a very alien planet, and many of us think that plate tectonics as we know it today was not operating during much of that time either. The rocks of the Archean eon look quite different than rocks of modern tectonic settings. It doesn't really look like a modern style tectonic system with subduction and rigid plates. Then we move into the Proterozoic eon, which spans a huge amount of time. It's almost half of Earth's history, from 2.5 billion to just 0.5 billion. And that was an interesting period. It's punctuated on both ends by ice ages. And importantly, at 2.5 billion years ago, we first see significant amounts of free oxygen in the atmosphere. So it was a huge change geochemically from basically a volcano breath atmosphere to one in which the biosphere, in particular photosynthesizing algae, were in control of the chemistry of the oceans and atmosphere. So starting at 2.5 billion, we have some free oxygen in the atmosphere. And then much of the Proterozoic was a very stable time. Life was around, but it remained basically single-celled for 2 billion years or longer. And then at the very end of the Proterozoic, we have kind of a climate crisis that is called Snowball Earth, a very deep ice age, much, much more, much colder than the Pleistocene that we're still emerging from today, where there were glaciers at the equator at sea level. So clearly a deep freeze. And this seems to have ushered in, it sort of cleared a lot of ecological niches and allowed a new biosphere to emerge when Earth finally warmed up again. And that's where we finally see the flowering of multicellular life. And that's the sort of beginning of the Victorian era geologic timescale, where there are macroscopic fossils that could be used to calibrate the geologic record. But again, that's just the last 500 million years, and we call that the Phanerozoic eon. And that word phanero means visible, so visible life. And in many people's minds, that's the geologic timescale. But again, that's just the sort of unlikely epilogue to a much, much longer story of life on Earth that has primarily been microbial since about 3.5 billion years. Then the Phanerozoic is subdivided into Paleozoic, Mesozoic, and Cenozoic eras. We're still in the Cenozoic era. The Mesozoic was the dinosaur time. Paleozoic was the time when, again, multicellular life first emerged and evolved. So I hope that's a breezy overview. But